Welcome back. And in this video, we are going to learn about relational algebra and how we form the expression for some of the given statements. So we already have seen different kind of operators like set operators. Then we have seen joins, different kinds of joins, and also we have seen some operators like selection, projection, rename, and all. So in this video, we are going to see how we can form a particular expression, and this expression has to be algebraic expression for a given relational data. For example, let's see that we have been given a statement like we have three tables: student, and student consists of three attributes like sid, s name, and age. Okay, and then we have another table like the course table, and in course we have attributes like cid, cname, and instructor. And then we have another table called enroll, and in this table we are having three attributes like sid, cid, which is our primary key. Then we have the grade. Okay, so now for given these information, if we have a query like retrieve sids enrolled some courses taught by court, some courses taught by court. Okay, so now here we have to see how we can check the course of the students, and also we need to check that the course has to be from course. So we need to see which table we need to use from here. So if you see, enroll contains the sid and cid, so this will give the student id which is enrolled in particular course. And from the course table we will see that which course id is mapped to which instructor. So we need to do the cross product of these two relation. Okay, now if we write for this an algebraic expression, so it will be enroll cross product with course, such that we need to select that enroll dot cid equal to course dot cid, because one student can be enrolled in multiple course. Okay, so we have to see that if s1 is enrolled in c1, so we need to choose c1, and and corresponding to the c1 we have to see that course dot instructor is equal to course. So corresponding to this CID, we need to see whether the CID has an instructor of course, and this CID is associated with this enroll CID. And from here, we need to retrieve phi enroll.sid, or you can simply write it as sid. Okay, so this is our corresponding algebraic expression, or you can say a relational expression for this above query. Okay, so this is how we are retrieving. Another way of representing the same via join is we need to do this conditional join of enroll and course, and we need to give a condition that enroll dot cid equal to course dot cid, and enroll dot instructor is equal to course. Okay, and from here we need to retrieve phi enroll dot sid. Okay, so we are retrieving enroll dot sid, and we are doing this kind of cross product. Okay, this also can be represented in another way, like just do the natural join of enroll and course, because we have the common attribute cid, so based on that there will be a natural join. Okay, so enroll natural join with course, and from here we need to retrieve here if we are saying it is a natural join, then definitely we will be based on the common attribute of enroll and course, we are doing the cross multiplication. And here just we are placing a condition that course dot okay, just a second. In the first, here I need to write course dot instructor. Sorry for this slip of pen. So it should be code, because in enroll we don't have a instructor, right? So it will be course dot instructor. I hope it's clear. Now let's say for enroll and course, we are doing this join, and then we are writing enroll. Okay, so we need to check the cid, that we can check from here. So we are doing just the natural join of enroll and course, and then we are writing course dot instructor equal to course. Okay, so this way we write, and then we take the projection of SIDs. Okay, so yeah, this is the way to retrieve SIDs of those students who have enrolled into courses. Yeah, that's it. And so these are the few ways. So let's see another question, because we have to this is one query, right? Now we need only course. So here we need, in this question, only only course. So we can do something like we can have phi cid, and we can place one condition onto course, that we need that the instructor should be course. So we will be retrieving the cid for only those courses which are being taught by course. Now let's say if we are doing this natural join with enroll. Okay, right? So if we are doing this natural join with enroll, so what we are receiving, so we are receiving those courses and those student id which are there in enroll, and whose course id is matching with the cid for course. Okay, so let's not just retrieve the course id, let's retrieve the entire attribute. So here we are just retrieving only those entries, only those tuples from course table that has an instructor of course. And then we are doing a natural join with enroll, and finally we are retrieving the sid. So this way also we can write the expression. So this is one another way of writing the expression. Similarly, you can replace this with cross multiplication and place a predicate condition that enroll dot cid is equal to course dot cid. Okay, so this way we can write. So this is some of the ways in which we can represent the queries, right? Similarly, let's see if we have R relation and it has attributes like A, B, C, and we have S relation and it has attributes like D, E, and F, and then we are doing natural join of R and S, and then we are taking out the projection of A or R dot A. So this has nothing in common, right? But we are doing this natural join, so it will be cross product of R and S, right? So this way we can represent. Let's say that here we are writing some expressions like b equal to female. Okay, and then we are writing like e equal to male. Okay, and then we are doing like and c is less than it. So we are placing some conditions onto this natural join. So first we are doing the cross multiplication of each and every attribute. So if they are all together for all this 10 attributes, so and here it is 20, then we are having 200 tuples. Okay, for this if there are 10 tuples, and for this if there are 20 tuples, so all together we have 200 tuples, because it is a cross multiplication. Okay, it is a cross multiplication, right? Even if we have some common entries, then also it is a cross multiplication because it is a conditional join. So altogether we have 200 tuples, and on this 200 tuples we are applying this condition, right? And from there we are retrieving or projecting the a attribute. So uh, is it not better that we can apply the condition before doing this join like this? So here what we were doing, that we were applying the condition on the natural join, right? Here also we were applying the condition on natural join or cross product. But here what we are doing, first we are applying the condition on course and just selecting only those tuples which have an instructor equal to course. So now the number of tuples reduced. So when we are doing this cross multiplication, we have less number of tuples to multiply, right? Similarly, in this case, if we do something like this, that we are doing r and natural join with s. So beforehand we just check that for r we have b is equal to female. So we are retrieving those tuples where b is equal to female, and for s we are applying condition and retrieving those tuples where e is equal to male. So now we have reduced the number of tuples by applying this selection condition, and then we are applying this conditional join of c less than f. I think yeah, c less than f, and then finally we are projecting the a. Okay, so now here just one condition check is there, and also the number of tuples reduced by applying this condition beforehand. Okay, so this is more efficient way of writing the relational algebraic queries than this one. Okay, so yeah, this is what I needed to explain. Similarly, we can check one more example to explain this part. So let's say we have relational relations like a, b, and c. Attributes are there, and then we have a relation s with attributes like c, d, and e. Now we need to check for this. So let's say we are doing the cross multiplication of r and s, and then we are applying condition like r dot a greater than equal to 10, greater than 10, and then we are projecting phi of projecting the a attribute from r. Okay, this way. Okay, now uh, is there any other better way for writing this? So yep, we can do like this. So we are first selecting r dot a greater than 10 from r, and here we are doing the cross multiplication with s, and then we are projecting the a. Okay, so now earlier applying this condition on r, we just have reduced the number of entries to be multiplied with s. So yep, these two are equivalent. But when the question comes for the efficiency, then we need to take those expression in which we have less in executing those expression, we need less time. Okay, so time complexity matters when we are writing this relational algebraic queries. Okay, and similar way, if we can also include a lot of conditions like s dot d is equal to less than 10, or r dot c is equal to s dot c, but the way we are writing does matter. Okay, now let's see another questions on the retrieval, how to write the algebraic expression for that. So let's say if we are asked to retrieve sids who got a grade for some courses for some courses taught by course. A grade for some courses taught by course. Now here we need to retrieve the SIDs of those students who got A grade for some courses taught by course. Now again we need to find first that what are the SIDs who got A grade. Okay. So if you go to the table and if you see here, so the grade will come from the enroll table. So what we will do first, applying the same principle, so first we will from the enroll table we will be retrieving the tuples where grade equal to A. Okay. And we need to retrieve the courses taught by court. So we will be applying this on course table and checking if instructor equal to court, right? And then we will be doing this natural join such that enroll.cid equal to course.cid, and from here we are applying the projection and taking out the SIDs. Okay, so this way, otherwise you can write it like a cross multiplication, or we can write it like enroll, and here we are taking the grade equal to A, and here we are doing cross multiplication with selection on course, and here we are saying that instructor should be equal to course. Okay, and then on the whole we are applying the condition like enroll dot cid equal to course dot cid, and from overall we are projecting A. Okay, so this way we can write down the expression or simplify down the expression. Right. Now let's see. There is one more question on like retrieve SIDs who enrolled some courses taught by court or some courses taught by Navathe. Okay, so we need to retrieve the SIDs who has enrolled into some courses like which is taught by Korth or Navathe, like that. So if there are some courses taught by Korth and some courses taught by Navathe, or let's say we have, so we need to retrieve SIDs which is present in these two. I mean any student who has enrolled either Korth course or Navathe course, like this. Okay, so for these kind of question, either you can take the union of these two, like we already have learnt about how to take the union. Okay, so first of all we can write it like first we need to take the union of SIDs who enrolled the course taught by court, and then we can take the union with the SIDs of the student who has taken Navate course, like something like this. So phi projection of SID, and here we are taking uh, okay, so it is enroll, first enroll, and then we are doing the natural join, and here we are writing instructor equal to course. This we are doing on course relation. Okay, just let me erase this. And then we are doing it union with by taking the SIDs for the enroll and natural join with course. Okay, and here instructor equal to Navate, right? So this way, if we do, then we can check it out for union. So this is one way of doing. Another way of doing is like you can do the cross multiplication and check, but I think this is the most appropriate way. By taking the union of both the SIDs, you can check whether it is instructor equal to course or Navate, right? We can write it like this also, like something like in a shorter term. So phi SID, and then we are doing enroll, and we are doing this natural join with courses. And for courses, we are taking up the those courses where instructor equal to course, okay, equal to course or Navate. So we can do or sign is like this. So or instructor equal to Navate. So yeah, so for this, if this is true, then also we will take the CID, or if this is true, then also we will take the CID. So like this, we can write it like down. So it is a more compact form of writing the same regular expression for the above one, right? Now let's see if there occurs a question in which we are asked to find out the courses taught by both course at Korth and Navate. So if they ask something like retrieve SIDs enrolled some courses taught by Korth and some courses taught by Navate, and some courses taught by Navate. So here we are asked to retrieve SID who is enrolled in courses taught by Korth and courses taught by Navate. So we have to find the intersection. Okay, so we can write that we need to find the intersection of the SID where these SIDs who are enrolled in courses taught by Korth, instructor equal to Korth, and this is a course, and we can take the intersection of phi SIDs and enroll natural join with course and instructor equal to Navate. Okay, so this way we can take the intersection of these two, and this will give us the SIDs who is enrolled in a course which has an instructor course, and also is enrolled in the course which has an instructor Navate. I mean those SIDs which are enrolled in both the courses, like courses taught by course as well as courses taught by Navate. So if this gives us S1 and this gives us S1, that means S1 is the student who has enrolled in course as well as who has enrolled in Navate course. So this we need to retrieve, right? If we try to write it in a compact way like we have written for the union part, so for that if we write something like this, phi SID, and then we are making the natural join of enroll, and from here we are taking the uh, course and retrieving instructor equal to course and instructor. So we are taking the sorry we are taking instructor equal to Navate. So here if you see what we are trying to do is we are taking the course ID whose instructor is course and whose instructor is also Navate. Like some courses, like if there is a course C1, so it is also taught by course and it is also taught by Navate. but we know that C1 is the primary key. So C1 cannot repeat itself for Korth and Navathe, right? So C1 has to be unique. So either C1 has to be taught by Korth or C1 has to be taught by Navathe, but not both. So this way, if we are trying to find the SIDs, it won't work. It will give us zero tuple. So this is not the right approach. Okay. So only we need to follow this long approach for that. Right. So yeah, this is the point here. And let's see one more question based on that. So let's say if we are asked to retrieve SIDs enrolled only SIDs enrolled only course courses. Okay, so if we need to find the SIDs which are enrolled in only core courses but not in any of other the courses, then definitely here we need to use the minus. So if this case consists of all the SIDs, okay, so from here we need to subtract those SIDs which are enrolled in core courses. Okay, so this we need to subtract out from here all the SIDs which are enrolled in core courses, and this will be our result like this. Okay, so we can do like this, that we can first try to find all the SIDs who are not enrolled in core courses. So we can do enroll and natural join with courses, and we need to take all those courses where instructor is not equal to course. So we can write it like this: instructor not equal to course. Okay, instructor not equal to course. So this will give all the CIDs whose instructor is not course, and from here we can find out project out the SIDs. Now these are the SIDs who have enrolled in non course courses. Okay, so if we want to find that okay, just a second, this is not our result. So this is our result actually. Okay, because these are the SIDs who have enrolled in only core courses. Okay, so this gives the SIDs actually who have enrolled in non-core courses. This gives the SIDs who have enrolled in non-core courses, and we need to find the SIDs who have enrolled in only core courses. So this part we need to find. So what we will do, we will subtract it from the SIDs, from the entire SIDs of enroll. We can subtract those SIDs who have enrolled in non-core courses, and the resultant will be our SIDs who have enrolled in only core courses like this. Okay, so yeah, this is the way we can write the expression. Now the next we will be seeing about division operation. So it is also a derived operation, but it is a little bit different from the it is a little bit trickier to understand. So let's cover it in next video. And that's it for this part. And if you do have any comment or questions, please do post in the comment section. Thank you very much.